Hey guys, this is Ben from Meshtastic, and today I wanted to talk a little bit about range issues and how to increase your range with Meshtastic devices. That's one of the things that we kind of get questions about the most on our online communities, especially Discord. So I wanted to go over some of the ways that you can increase your range or troubleshoot any range issues that you might have with your existing mesh. So the first place that I would like to bring up to look at any potential improvements is actually just the Meshtastic settings themselves. So when we're looking at setting up our mesh, if you go with the default settings on the primary channel, what you're essentially opting into in terms of the LoRa radio presets that we have defined in Meshtastic is what's called the long fast channel. And we chose that channel in Meshtastic 2.0 to be a little bit higher bandwidth in terms of the total throughput, because a lot of folks found that Meshtastic 1 was a little bit slow on the default settings in terms of the snappiness of messaging. So we tried to find a good compromise there, and we ended up with this long range fast. So there's a little bit of a sacrifice there, though, with each of these faster presets that you choose. You actually lose a little bit of what's called the link budget. So the link budget, a good way to think about that is sort of your total signal strength that is possible given your radio and radio configuration. So these faster channels, the short range fast being the fastest, offers you a much higher transfer speed. In this case, 6.8 kilobits per second versus 0.67 kilobits per second on our default of long fast. But that comes with the sacrifice of the link budget. There's not as much range that you're going to experience using those settings. Now, I will say this document was created with a assumed transmit power of 17 dBm. So that's kind of on the low end, I would say, but this is just kind of a reference point to sort of just compare the different channel settings and their link budget, speed, etc., and to illustrate their some of their LoRa radio settings. So we have several things in here that I won't go into, such as spreading factor, encoding rate, and bandwidth, but suffice it to say, each of these parameters that are programmed into these presets have an effect on your total link budget and thus your range that you're going to get with your LoRa radio. So having said that, I mentioned, the higher we go on this list with the faster settings, the less of a link budget we get. But conversely, if we go down to these slower settings, you get more of a link budget. So you could potentially increase your range by going with a slower preset. Now that has a downside. You will not get as much network throughput, and what that looks like in the application on your phone apps or your CLI clients or what have you, you will notice a lot more latency with sending and receiving messages and acknowledgments. So that's just something to look at. If you've got a smaller mesh, you might look at going down to long range moderate, which will still be somewhat snappy, but will give you a little bit more in terms of link budget. So you might increase your range a little bit. Another setting that you can look at, and this one is actually dependent on your radio. So there's two major types of LoRa radios that are built in to Meshtastic devices. The SX1276 is by Semtech is built into this particular T-beam right here. And the SX1262, which is a higher power radio, is built into this Heltec wireless stick light here. So one of the things that I recommend folks do is spring for the extra money to go for the higher power SX1262 radios. I know this particular Heltec is actually pretty cheap, but I know if you're purchasing from LilyGo, a T-beam, the SX1262 chip will cost you a little bit more, but I think it's totally worth it for two reasons. So this stock, and let me just, while we're looking at this, great way to tell if you've got an existing device, if you have a SX1262 on your LilyGo, is it will clearly state it. So right here we see this one has SX1262. If it doesn't, if it just says LoRa 32 on it, then you do not have one. But a couple of reasons why I like the SX1262s better. So this particular T-beam with the SX1276 can only transmit at 20 what's called dBm output. And so that's around 100 milliwatts. Now this SX1262, on the other hand, can transmit up to 22 dBm. So you get an extra 2 dBm of output. That's around 160 milliwatts. But that's not where it ends. So there actually, there is a setting that you can enable within Meshtastic. If you're looking at the Python CLI, it's LoRa.SX12X RX boosted gain. And what that does is these radios, by default, these SX1262s and their analogs, have power saving mode enabled on the RX front end. So they are essentially not receiving at the highest sensitivity they can by default. But we can change that by changing a register, and that's what we do with that setting. So our in our firmware, if you set that RX boosted gain mode, you will get a few extra dBm on your link budget potentially. And I've noticed a pretty significant increase in range doing that. So I highly recommend these for those two purposes. There's a slight power penalty, but it's only around 1 milliamp, something like that. It's pretty inconsequential. So so there's a lot of different devices around. So here is a LoRa 32 from LilyGo. Most of these you will see have the SX1276 radio. So you can upgrade the newer ones. I believe it's called the T3S3. They have a SX1262 option. So look out for that. Again, you will pay a premium, but I think it's worth it. All of these new Heltec boards, so the wireless stick light V3 and the Heltec LoRa 32 V3 also has, every one of these has the SX1262. And I recommend these if you're wanting to get started with a really cheap device. They're very affordable. They're kind of quirky. I don't recommend them for battery-powered operation, but in terms of pure power, they're great. If you have older Heltecs, a good way to figure out if you've got the V3 or not, if this is USB-C, you have the V3. If it's micro USB, you've got the older ones, which I don't recommend at all. Those are very quirky devices. In the world of rack wireless, everything is SX1262. This is one of the reasons why I really like Rack Wireless's offering. So here we have their ESP32 version with external modem, and here's the popular Rack 4631 option. The Meshtastic starter kit will include this core. Very good performance out of these. So something to look at. There are also DIY options. So I've got this little DIY board. Some of you folks may know from the Discord. This is called the Hydra, and it's a project that I help work on that uses a particular e-byte radio module that features the SX1262, but it also has an integrated amplifier built in. So this can actually achieve 30 dBm or 1 watt when configured correctly and given enough power. So those are options. Also take a look. Our website has a lot of documentation around devices. So go look there. Neil Howe's Nano series is a really great place to look for higher power devices. So I would recommend that you check that out as well. Another thing that I want to talk about with regard to range that a lot of people have problems with, and that is antennas. So if you purchase a LilyGo device, you may recognize this antenna. You may recognize this one. I recommend that you throw both of these in the trash because they are frequently not even matched to the band that you're on. I have personally measured these on my Nano VNA, and this is plug for Nano VNA. They're not paying me anything for this, but this is a great tool if you want to challenge your assumptions about whether or not your antenna is actually tuned to the band you think it's tuned to. And there's a ton of videos about this. It's about a $50 device, and it's very good for checking the resonance of an antenna for a particular band. So that's something to look at. But these antennas that come with the device are generally not great. So we have, I will say, the rack wireless little PCB antenna is actually great in terms of resonance, but it is a very low gain antenna, so you won't get too much range out of that. So what I recommend is actually for everyone to go to the Meshtastic documentation and look at the antennas there and the links there. I also recommend going to the Meshtastic Discord server. There is an antennas room that is very helpful. There are people there that are knowledgeable that explore all this. So having said that, here's a few options that I like. One of my favorite antennas, and this one does not have a flexible joint like the others, but this is a Lynx dipole antenna. You can get these off of DigiKey or Mouser or any of the major electronic manufacturer websites. This is very well tuned. It is a dipole. It costs around $10-ish. Absolutely worth it. There's also an option from Tau Glass. It's very similar. I believe they call that the terminal antenna. Another really cheap option that shout out to Neil Howe, he posted on Discord, is this Zysor. I don't know how you say it, but you can get these on AliExpress, and it's similar to the rack blade antennas. These are very well tuned, but the thing that I really like about this is it is a dipole, but it is a good sleeve dipole where bending this joint does not affect the resonance. A lot of times you'll get these bendy antennas and you'll put it on the Nano VNA here, and then you measure it straight. Hey, it's great. It's 915, bang on. And then you bend it, and now it's way over here to 700 something megahertz center band. So these are great. They're cheap. Go to the Discord and you can find the links. I think they're pinned. But I highly recommend those. You will probably have to wait because it's AliExpress, so probably take 2 weeks to get to your house, but I think well worth it. You can order a ton of them. So another thing that can happen. So let's talk about connectors really quick. So rack wireless, for instance, and some of these T-beams have IPX connectors instead of SMA. Now, one of the things that you can really get into trouble with is choosing the wrong pigtail to connect to your antenna. So I have two different types here, and there's a very subtle difference between them. One is standard SMA, and one is what's called reverse polarity, or RP SMA, right here. So you want to make sure that your antenna, in this case, you can see this Lynx has a center pin that protrudes. So you want the standard SMA antenna. So you can screw that on. If you attempt to screw on a reverse polarity SMA, or better yet, you have an antenna that has that is reverse polarity SMA, and you screw on a standard one, you will have no contact. So you will get a terrible signal, and you may even damage your radio over time if you're not careful with that. So always check this. It's an easy mistake to make, especially if you're buying aftermarket pigtails to SMA. So something to look at. Another thing that I want to talk about a little bit is antenna gain and antenna type. So I mentioned earlier, this is a dipole, this Lynx right here. Right next to it, I have an offering from Tau Glass, which is a monopole. So this is just a single element of wire. So the neat thing about a dipole antenna is inside there are two elements, presumably of equal length, and each of those elements is tuned to a quarter of the wavelength of the band that you're targeting. A monopole is not quite the same. It is a single element, and it uses what's called the ground plane of your device. So your PCB of your board actually is part of the ground plane to essentially make up part of the counterpoise for the antenna. So that kind of falls apart on a lot of these smaller devices because they don't have enough of a ground plane to make this antenna really resonant on 915 megahertz. So this antenna actually works really well on top of a car with an SMA mount, one of those magnetic mounts, because the top of your car is an excellent ground plane. So these antennas, they look really cool. Everybody likes neat little bendy whip antenna, but just be careful with these, and you can measure them and see how resonant they are. But that's one of the things to look at. Another thing to look at in terms of antenna, and this is something unfortunately a lot of folks lie about in terms of vendors, is antenna gain. So I've got an incredibly large outdoor antenna here from Rockland. This one is a 9 dBi antenna, and so this antenna presumably has more gain than a standard dipole, which offers generally around 2 to 3 dBi max. So this antenna offers a lot more power radiating out of it, essentially. And the way that gain works with antennas is you're not getting power from nowhere. This antenna doesn't magically boost your signal. It actually becomes more directional. So if we're looking at sort of a chart of how the antenna radiates the radio waves, a dipole is very much a omnidirectional sort of circle around the antenna, whereas this higher gain antenna is actually more like narrower triangles, if you can imagine cones coming out of the antenna. So there's a sacrifice there. So this is great if you're, say I'm putting this up in the neighborhood and things are pretty flat. I just place this somewhat high up and I can increase my range. But if I'm at the base of a hill and I place this up parallel or perpendicular to the ground, and I'm wanting to make contact with the node at the top of the hill, this will work not so well because of the distorted field that this produces, because it's more directional. So you might want to go with a dipole in that case. So that's something to look at. I always recommend choosing a really good, dependable dealer for your antennas. I would generally steer clear of Amazon. I would go to Rockland or DigiKey or Mauser to choose more professional brands that have a little bit better reputation than some dubious antenna on Amazon, even though it's we all know it's attractive to get an antenna in 2 days with Amazon Prime. So another thing that we can look at past antennas is actually looking at where our mesh is going to be deployed. And one of the tools that I like to do to get elevation profiling is to go to heywhatsthat.com. And the thing I like about this website, so there's several different features that you can use. One of them right here, I've got the panorama, so I can select a point on Google Maps. I can say how far off the ground the node will be, and then I can make essentially like a heat map to see, okay, where do I have line of sight from this point? So this is really great because line of sight in RF communication systems is really critical. Even in two-way radios, if you're behind a hill and I'm behind a hill, there's a good chance that we might not be able to talk. And the same is true of Meshtastic. These things have incredible range, but that starts to fall apart when you start introducing a lot of terrain or skyscrapers or any sort of obstacles in a serious way, especially as you move further from your node that you're trying to make contact with. So I really like this tool. It has a lot of utility. It also has this path profiler, so you can see your line of sight path, and if there were hills, it would show you where that sort of intersects with your particular path there. So I recommend this tool, particularly if you're planning a repeater or a home node or any sort of static node. This is very helpful. This will help you achieve the best range that you can based on placement. So I guess that's kind of it. As always, if you're having issues, feel free to go join the Meshtastic Discord server and reach out. There are a lot of helpful people there. There's a lot of good information there as well. And good luck.